6, Trigonometry 1. So the objectives today then to understand what trigonometry is and how it's used, to be able to use the trig functions on a calculator, and to work out the missing length in a right-angled triangle using trigonometry. Before we start, we need to check our prior knowledge. So we should be able to identify the longest side on a right-angled triangle, that being the hypotenuse. So remember, it is opposite the right angle, so the diagonal side that's opposite the right angle is always the longest, and you should be able to substitute values into a formula. To be able to complete this lesson, things you're going to need then, you need your maths book or some paper to write on, a pen or a pencil, and most importantly for this lesson, you're going to need a scientific calculator. So hopefully most of you should have this Casio type calculator, this one, or the slightly newer version, but it does need to be a scientific calculator for today's lesson. Okay, before we start then, we're going to have a look at those calculator functions, so it'll help if you've got your calculator in front of you. So the first thing we're going to do is we're going to make sure that our calculator's in the right mode. This is really important for trigonometry. So to be able to make sure we've reset our calculator to the appropriate mode, you need to press the shift button, then 9, 3 equals, and then the AC button. Can you make sure that you've done that? Once you've done that, you should see a small d appearing at the top of the screen. So make sure there's that small d at the top and none of the other letters there. Okay, so now we've got our calculator into degrees. Degrees is the mode we need for using trigonometry because we're going to be measuring our angles in degrees as opposed to perhaps radians or something else you might use in science. So that's why we need to make sure our calculator is reset, ready for degree mode. Other buttons that we're going to be using today then, just to make sure you're familiar, this one here is our fraction button, so we're going to be using that to help us to put in our calculations. These here are brackets. You should be quite familiar with using your brackets. We're going to be using those, and our new buttons that we're going to look at today are these three here, the ones that say sin, cos and tan. They are our trigonometric ratios. They're the ones we're going to be focusing on using today. So make sure you're happy that you've got all of those buttons. And if you have a different style of calculator, you know where they are on your calculator. Okay, so trigonometry then. What's trigonometry? Well, the word trigonometry comes from Greek and it means a triangle measurement. It uses the fact that the side lengths of similar triangles are always in the same ratio to find unknown sides and angles. Okay, so for example, when one of the angles in a right angle triangle is 30 degrees, the side opposite the angle is always half the length of the hypotenuse. So here we've got a triangle then. We can see it's a right angle triangle because it's got our right angle in the corner. Our longest side, our hypotenuse here, is 8 centimetres. And we've been told this angle is 30 degrees. So one of the things we can use trigonometry for is to find the length of the other side. So in this case, this side here. Now, if it's a 30-degree angle, the opposite angle here is half the length of the hypotenuse. So if our hypotenuse is 8, then this length is going to be 4. And that's the relationship between the ratio of the angle and the side. So if I have another right angled triangle here, a slightly larger one, again right angled, I can see the hypotenuse here is 12. I can see that the side opposite the angle, opposite meaning on the other side of the triangle, is 6. Now 6 is half of 12, so therefore this angle must be 30 degrees. So that's what we're going to look at over these next couple of lessons, is if we're told a side and an angle, can we find the lengths of other sides? And if we're told the side lengths, can we find other angles in our triangle? So today we're going to start by doing this one where we're going to find some side lengths. So important thing we need to know then is the three different ratios. So here we've got our right angled triangle. We've got our hypotenuse labelled opposite the right angle, remember the hypotenuse. And we've labelled the angle here with this symbol. Now this symbol is called theta. It's a Greek letter. We use it when we want to identify an angle. So this is an unknown angle. So we could use other letters. We could use, A and X and other lowercase letters if we wanted. but theta is our sort of universal symbol for angle. We've labelled this side opposite. There's our angle. If we go opposite to the other side, we've called that opposite. And the one next to the angle, we've called adjacent. We'll talk about those a little bit more later. What I want us to have a look at is our three ratios. So our first ratio is the sine ratio, and it says sine theta is equal to the opposite over the hypotenuse. Remember, this line here, this over, is a division, so the opposite divided by the hypotenuse, but we can also use our fraction button to represent this. And you can see that in blue there, we've got the first letter of each word in bold blue, and they make the word so. Our second ratio is called cosine, and cosine theta is equal to the adjacent over the hypotenuse. We use the word car. And our third ratio is tangent, so tangent theta is equal to the opposite over the adjacent. We use the word TOA. Now you notice that each of our ratios is with the symbol for our angle. Okay, so every time we use these three words, sine, cosine or tangent, it is the sine of an angle, the cosine of an angle, the tangent of an angle. That's really important that we don't forget that those words have an angle that follows them. Now we've got our three words here, so, car, TOA, and that's the mnemonic we use to help us to remember those three different ratios and which sides they relate to. Please make sure you pause the video and make a note of this. This is really, really important. Okay, so a way to help us to use our three ratios are these. These are called trig triangles. Now these are very much the same as speed, distance, time triangles or density, mass, volume triangles that you may have used in science. They work in the same way. So you'll notice that the three letters, so, car and TOA, they start at the bottom left, then up, then down. They always follow that pattern. So, car, TOA. When we see these triangles, if something is next to something else, they get multiplied together, and over means they're divided. Okay, so if I want to find, S stands for the sine theta. So sine theta is equal to the opposite over the hypotenuse. So if I cover up sine, then I can see that I'm left with O over H. If I wanted to find the opposite, if I cover up the opposite, I'm left with sine theta next to H. So the opposite is sine theta times the hypotenuse. And finally, if I want to find the hypotenuse, if I cover that one, I'm left with O over S. So the opposite over sine theta. So hypotenuse is opposite over sine theta. Now again, that works the same for each triangle. So if I want to find cos theta, I have A over H. Okay, so it works the same for each one. So I'm just going to put those up there for you. Again, make a note of this in your book. So pause the video, draw out the triangles and write down the three different formulae that we can use for each triangle. All right, so now that we've got our ratios, the next thing we need to know is how to label our triangles. We need to make sure that we know which sides have which names. Okay, so when we did Pythagoras, the longest side was C, and it didn't matter which side we called A and B as long as they were the shorter sides. With trigonometry, it's quite different. The sides have specific names, and it does matter that we get them the right way round. So let's start with this one then. So we've got our hypotenuse, which is opposite our right angle. So again, hypotenuse we should be most familiar with. It's our longest side. The other two sides are labelled depending on the angle that we're interested in. So at the moment we're interested in this angle here. So if we go across from that angle to the opposite side, we've called that opposite. And the one next to it, so the one that's touching it, is called adjacent. Here we've got the same triangle. Our hypotenuse is still in the same place, opposite the right angle. But our angle now is up here, which means that its opposite is at the bottom this time. So we follow directly across to get the opposite, and the one next to, the one touching against the angle, is the adjacent. So the hypotenuse is always the longest side, but the adjacent and opposite swap depending on which angle we're interested in. Okay, so our key point then for this bit of the lesson, so the side opposite the right angle is the hypotenuse, the side opposite angle theta is called opposite, and the side next to angle theta is called the adjacent. Please make a note of that in your book. Okay, let's just check that we've understood that correctly. So there you are, there are 4 triangles there. You need to copy the triangles and you need to write H, O and A, H for hypotenuse, O for opposite and A for adjacent by the correct side. So pause the video, have a go at that now. All right. So I always find it easiest to start with my hypotenuse because I know my hypotenuse is the longest side and I know it's opposite the right angle. So we've got our hypotenuse. The opposite is opposite the angle, so I follow my angle across and I get my opposite. And the one next to my angle is my adjacent. So the same for this one. Again, I'm going to start with the hypotenuse. So from the right angle, my longest side is my hypotenuse. Follow my angle across and I get my opposite. And the one that's left is my adjacent there, next to my angle. Down the bottom here then, so my hypotenuse, if I'm not sure because it's twisted around, looks a bit odd, I follow across from my right angle, I get my hypotenuse. Across from my angle, I get my opposite. And the one touching against my angle is my adjacent. And finally this last one then, so again, opposite the right angle is the hypotenuse, opposite the angle is the opposite, next to the angle is the adjacent. Make sure you're happy with those. It's really important that we can label these correctly. If we don't label them correctly, we will end up choosing the wrong ratio to use and we won't get the correct answer for our questions. So this first step is a really important step. Make sure you're happy with which is the hypotenuse, which is the opposite, and which is the adjacent. Okay, so let's have a look then at how we're going to use trig to find these missing lengths. So if we're given one side and one acute angle in a right angle triangle, remember we're only dealing with right angle triangles at the moment, we can use one of the 3 ratios to find the other lengths. So here we are, we've been given a right angle triangle, we've been told one of the sides is 12, an angle of 56 degrees, we can see it's a right angle triangle and we're asked to find the length of this side here, x, and we're asked to give it to 2 decimal places. So our first step is to figure out which side have we been given and which one do we want. Excuse me. So we've been given the hypotenuse, so we're going to label that h, and we want to find the length of the opposite side. Here's our angle, this is our opposite. Now we're only labeling those 2, okay? I would suggest you avoid labeling all 3. We should only be labeling the thing we want and the thing we're given. If you label all 3, you can then get confused about which ratio to use. If we only label those 2, it makes it a lot easier. So remember, we're only labeling the information they've given us and the information we want to find. Now we need to decide which of our 3 ratios to use. So that's where we use this word SOHCAHTOA. So we have been given the hypotenuse. So 2 of those words have H in for hypotenuse. We want to find the opposite. Only 2 of those words have O for opposite. Now only one of those 3 words has 2 things circled, and that will always be the case. Remember, we have only labelled 2 things, the one we have and the one we want. So we will always end up with one word with 2 circles, and in this case it's the word so. Now we know it's the word so, I'm going to draw my so triangle to help me. We want to find this value x, which is the opposite. So we're going to cover up opposite in our triangle. We cover the thing we want to find and we look to see what we're left with. So we're left with sine theta next to hypotenuse. So S next to H means we're going to multiply them, and we're going to multiply the sine of the angle with the hypotenuse to find X. So we write that down. So X, the thing we want to find, is equal to the sine of the angle. Remember, our ratio must have an angle, and our angle was 56. Now, when you put this into your calculator, you'll notice that if you press the word sine, it puts in this open bracket already for you. We then put in our 56 and we must close the bracket. That's really important. If we don't close that bracket, we won't get the right calculation. And then we're going to put in times 12, which is the hypotenuse. So if you don't put this closing bracket after the 56, your calculator will do 56 times 12 first and find the sine of that answer, rather than doing sine 56 times 12. So do make a note of that and make sure you close those brackets. Now all we've got to do is type that into our calculator then. So we're going to type in sine, gives you the open bracket 56, close the bracket times 12, and we get an answer of 9.9484, etc. So remember, we always write down at least 4 decimal places before we do any rounding. And we've been asked to round to 2 decimal places. So 1, 2. Our third decimal place is greater than 5, so our second decimal place needs to go up by 1. We get 9.95 centimetres. Don't forget your units, we are measuring a length. Okay, so there's quite a lot there for you to take in. Make sure you've practiced that on your calculator to make sure you're getting the right answer before we move on. Okay, we're going to do 3 more examples. So remember, examples are there for you to work through with me so that you can see all of the steps and make sure you're happy with the process that we're following. So we're going to start the same then. We're going to start off, first step, remember, we're going to label the information we've been given. We've been given this 6 centimetres here, and that's our hypotenuse. We label the information we want to find. We want to find X here, and that's opposite the angle. So we're going to label that O. So it's O and H. So of our 3 words, so, car or tower, the only one with O and H in is so. As you practice that, you will get much quicker. You won't need to write out the words every time. Okay. Once we have that, we can draw our so triangle. It's really quick to just draw a sketch of this triangle. And we would like to find O. So we're going to cover up O. So I've covered it up with a green spot. You can just put your finger over it. That way you can keep using these triangles over and over. So we're left with sine theta next to the hypotenuse. So it's sine theta times the hypotenuse. So X is equal to sine theta, our angle is 44, times our hypotenuse, which was 6. Again, making sure we've closed that bracket. We get 4.1679, etc. And then we round appropriately. So 4.17 centimetres to 3 significant figures. So remember, if we're not told what to round to, 3 significant figures is the norm. Let's do the same for the second example then. So first step, label the information we have. So we've been given this side and it's the opposite side. So that's our opposite. We would like to find this one, and this is next to the angle. So that's the adjacent side. So that's why I'm labeling this triangle. It's really important we get the right 2. So from so, car or tower, the only one with O and A is tower. So we're going to use tower this time. So there's our tower triangle. We'd like to find the adjacent. So we're going to cover up the adjacent and we're left with O over T. So that's the opposite over the tangent of the angle. So our letter then X is equal to the opposite, which is 5.1 over the tangent of our angle 31. Again, closing our bracket. We get 8.487, etc. And we're going to round to 3 significant figures. So 8.49 centimetres. Finally then, our last one. So again, we're looking, there's our angle, we've got the side next to it, so that's our adjacent. We want to find this one. This one is opposite the right angle, so that's our hypotenuse. So A and H. So car is the only word with A and H in. So we're going to use our car triangle. Now we'd like to find H, so if we cover up H, we're left with A over C. A being the adjacent is 15, over C, which is the cosine of the angle, so cos 65. Put that in our calculator. We get 35.4930, etc. To three significant figures. Remember, three significant figures, the first three digits. 1, 2, 3. So our 9 makes our 4 into a 5. And we get 35.5 centimetres. Make sure you're happy with those before you move on to have a go yourselves. Okay, so now it's your turn. Pause the video, work through these three questions in the same way. Make sure you write down your mnemonics, so car tower. Make sure you label the side you have and the side you want to find, and use your trig triangles to help you decide whether you're multiplying or dividing. All right, let's talk through these then. So we were given the adjacent, we'd like to find the opposite, means we're going to use TOA. We've got our trig triangle, so we're going to cover up the opposite, which means we've got tan theta times the adjacent. So the tangent of 44 degrees times the adjacent of 10 gives us 9.6568, etc. And we're going to round to three significant figures, giving us 9.66 centimetres. For the second one, we've been given the hypotenuse and we want to find the adjacent, so we're going to use car. So we draw a car triangle. We want to find the adjacent, so we cover that, leaving us with the cosine of theta times the hypotenuse. So that's the cosine of 44 degrees times a hypotenuse of 12. That gives us 8.6320, etc. And to three significant figures, 8.63 centimetres. Finally then, we've been given the adjacent. We'd like to find the hypotenuse, so we're going to use car again. There's our car triangle. This time though, we want to find the hypotenuse, so we cover the hypotenuse and we're left with the adjacent over the cosine theta. So the adjacent was 4.5 over the cosine theta was 37, and that gives us 5.6346, etc. to three significant figures, 5.63 centimetres. Check your answers. If you have made any mistakes, just go back and check at which point you've made those. Is it labelling the triangle? Is it choosing the appropriate ratio? Is it deciding if you multiply or divide? So just check through and make any corrections you need. Okay, so now we're going to have a go at using this in a real life context then. So we've been told a 7 metre long ladder is resting against a wall. The angle of elevation is 72 degrees. What height does the ladder reach? Now when it says angle of elevation, that's important. Angle of elevation is from the ground upwards, okay? So we know it means this angle here and not these angles up here, okay? So angle of elevation is from the ground upwards. All right, so that's the one we've labelled 72 degrees. So again, we're going to start in the same way. We've been given the hypotenuse here. Now we know this is the hypotenuse because the wall and the ground make a 90-degree angle. So our ladder is the hypotenuse. We want to find the height up the wall. Our angle is here, so this is the opposite. So we've got the opposite and the hypotenuse this time. So that's O and H. So of our choices, there we are. So has O and H in it, none of the others do. So we're going to use our SO triangle. We'd like to find the opposite, so we cover opposite, and we're left with sine theta times hypotenuse. So the sine of theta, which is 72 degrees, times our hypotenuse, which is 7, gives us 6.6573, etc. And we round appropriately. So we're going to round to 3 significant figures, or 2 decimal places, 6.66, and our unit this time is meters. So we're doing the same thing, but this time we're given a question where we might be given a diagram. We may just be given the words, and we may need to draw the sketch ourselves. So it's important we know where the right angle is. It's important we know what the word elevation is. So our key point then from these real life questions, the angle of elevation, as we can see, E is measured upwards from the horizontal. So just as we did with our ladder. The angle of depression is measured downwards from the horizontal. So if I were to draw a line from the top here and I want to look down, then that's the angle of depression. We'll be moving on to look at that a bit more next lesson, but we definitely need to make sure we understand angle of elevation first. So do make a note of that in your book. Okay, finally then, your turn. So another real life question. So a flagpole is 20 meters high. It's supported by a rope at an angle of elevation of 42 degrees. How long is the rope? So we've been given here our flagpole, 20 meters high. We've got to imagine there's a rope coming down from the top. Okay, and the angle of elevation, so that's from the ground up. So we know again it's this angle at the bottom here and not this angle at the top, is 42 degrees. And the ground and our flagpole will always make a 90-degree angle. So whenever we've got the ground and something going straight up from the ground, that's always going to be our 90-degree angle. Pause the video, have a go, see if you can find the length of the rope. Okay, so let's make sure we know which things we have then. So we're being asked to find the hypotenuse and we've been given the opposite. So we want the hypotenuse, we've been told the opposite, so we're going to use SO again. So our SO triangles there. We want to find the hypotenuse this time, so if we cover hypotenuse, we're left with opposite over sine theta. So our opposite side is 20 meters over the sine of our angle, which is 42 degrees. Put that into our calculator, we get 29.8895, etc. And we've rounded that to 29.9 meters to 3 significant figures. Okay, so we've done quite a lot there today then, quite a lot for you to think about. So nice new topic there, lots involved. So it is worth doing a little bit more practice. So you can, if you want to go online, if you go onto our Active Learn system, then you can have a look at the online textbook, choose a few more questions and give those a go to make sure you're secure in that before you attempt the homework tasks. Okay, thank you for working through this lesson then. Next lesson, we're going to be looking at how to find the angles using trigonometry when we're told the side lengths.